Now that I have these curves set up, I'm going to create a collision object at the center so that when particles or pyro are advected down these curves, they have something to collide against. Otherwise, they would just pass through each other. So we're going to create a disc-like object in the center that will create the splash motion that we're looking for. So first we need the center point that we've created. And just to make it easier to call later, I'll just create a null off to the side and call it out center point. Then we're going to need to create a sphere, and we're going to create the sphere at origin, and we're going to create a polygon sphere and increase the frequency to something like 20. And so we want this sphere at origin because we're going to first flatten it. So we'll take a transform. And we're going to do something like this, where I'll take this in the x-axis, squish it down, and then I'm just going to make everything else around it a bit larger. I'll bring the scale down of it overall to 0.9. Cool. So now we are going to copy to points, just to see what we have going on right now. So there's our collision object, and here are the curves. So we can see right now that it's not correctly aligned. What it should be doing is facing up and down the curve. So in order to do that, first we're going to have to get a normal attribute onto this point. Right now, if we look at normals, we can see that it doesn't have anything. But that's pretty simple to add. First we go into this curve, and then we're going to create a polyframe. Add that in the chain, and then where it says tangent name, we'll make that our normal. And so then now if we go here, we can see that that has created a tangent along the curve, and that's our normal of it going along the curve. So if we go over to here, we can see that it is not aligned correctly, but that's fine. We can rotate this 90 degrees, and now we have it facing perfectly along this curve. Now that we have the collision geo set up, we're going to want to try to manipulate this geo to have it be able to curve inward and outward. So in order to do that, we are going to need to do a point wrangle. And one of the first things we need from this is a center point, and we need a gradient along this geo that we can use to multiply the point position around this to give it sort of a controllable bell-like shape. So first, let's just give ourselves a color ramp. So we'll just say CD equals. So we can get the center point by doing get bounding box center of this object minus each individual point. And that looks cool, but what we need now is the length. And now we have the further something away is means the longer the length of the vector is that I'm creating from the center point to the outer point. It knows that this point is farther away than this point. So this point is dark, this point is light, because the length here is less than the length here. And then I want to be able to manipulate this color value. So we're going to just go down and manipulate one of the channels, the X channel or red channel, and we need to create a ramp. So we're going to do channel ramp, ch ramp, And then we need to name our ramp, so we'll just call it color ramp. And we need to be able to fit the value of the length of each point into whatever it is to 0 and 1. So we'll do this value, which is the color value. So we can look at the position here. Let me just disable this. So we can look at the position. Since it's a circle, it doesn't really matter which axis that we look at, but we can see here the furthest distance is 1.8. So we can say the values that we have here are 0 to 1.8, and now we want it to be 0 to 1. So let's just say that our whole thing, our color is now equal to just the red channel that we're manipulating. I'm gonna reactivate this. Oh, I forgot to fit. And fit, not fit 0, 1, because 0, 1 is assuming that there's a 0 to 1 value, and we definitely do not have that right now, so we are defining our original range. Okay, so now that I have this ramp, I can start manipulating this gradient, and I can do something like this. Though it's gonna look a little harsh, so I think instead I can take these values, this, and then instead of it being linear, I can create a B-spline. So if I make new curves, then it's a more of a Bezier curve. So now I can do something like this, and I can use this to manipulate the point position by saying something like position X. Whoop. I guess here we have it in the Z value, so I'm going to do P.Z plus equals CD X. So then now I get this bell curve. But let's say that it doesn't curve back quite far enough. I can just create a multiplication and say mult. And since it defaults to 0, it's going to go to 0, but then I can use this, and there it is at 1, there it is at 2. Okay, that's doing stuff that I want it to do. So I can just change this however I want. So then as this fight goes on, let's just look at this here. So clearly right now it's too small. So I'm going to take this, make it much larger. Actually, now that I have the shape, instead I'm going to make it larger after the fact. Here, let's say, this should be about 10 times larger, something like that. So now, this can be the collision object, and whenever it is really close to him, I can say I want it to be curving around him. So instead of it being a negative 1.3, I can do 1.3. And see, now he has a shield that when these two beams collide with each other, his beam is going to be wrapping around and covering over his beam that's being deflected back and around. And so I can do something like this. Since it starts probably around here, he's losing, but around 1078 is when he starts to overcome the beam, So as this does something like this, I can bring this back to 0. And then as his beam starts to lose, I can make this negative 1.3 to show that his beam is now overtaking the villain's beam. And we can kind of see how this plays out here. I'd probably actually want this to start turning around there. Yeah, something like that. I think that looks pretty cool. Another thing we'll want to do is, right now this is a very perfect shape, but we want to add a little bit of variation when it hits this object, so it's not just a perfectly round cylindrical fall off as it's hitting it. So we're just going to add some noise. So we'll do a point VOP. Adding noise is a lot easier, I believe, in point VOPs than wrangles, but it's one of the only things that I do in wrangles, or that is not in wrangles these days. So we'll just do something like turb noise, take the position, we'll do an add, make sure that this is 3D noise. I prefer simplex noise for something like this. We'll just add it in. We'll promote all these. For those unfamiliar, you just middle click this, hit promote parameter. I usually don't mess with attenuation, at least for simple things like this. So now if we look at this, might be okay, but let's see, I'm gonna reduce the frequency, increase the amplitude, lower the roughness, and then the offset. I'm gonna do something like this, so that over time it moves. Going a little slow, so let's just keep it at 1 for now. Yeah, something undulating like that. I also think that this is too thin for our collision object, so I'm going to go here where we have this, where we're scaling it in. I'm going to do something like that to, I don't know. Now that's a bit too thick. 2.5, something like that. Cool. So now if we look up here, you can see I've got some sort of view report error. Yeah, I think that'll do. So one thing I've just realized is that I've set this scene up before, and the values that I have are a bit different, and that's because the scale that we're working at, even though we've brought it back down from Maya scale wise, we still actually want to go smaller. So the animation that I got was pretty large. I'm going to bring back everything actually down to 0.01. If we look here, with the magic of Houdini, everything is still exactly how it should be. The only thing that I need to change now are the values of this collision object, which is now way too large. So here I can bring this back down to 1, and now my amplitude too large, my frequency too low, but now this is closer to what I think I should be working with. So I'm going to increase the frequency of this just a little bit more. And then reduce the amplitude a bit. Yeah, I think something like that looks pretty good.